Good day, grade 11s. Today we are going to look at the reduction formula that involves 90 degrees. Before we get to this, let's just look at this the two quadrants, the first and the second quadrant. Okay, what I have done here is that I just want to introduce the concept of 90 minus theta. Okay, you see this green angle here. This green angle is 90 degrees. Okay, because we know most from zero. The first quadrant lies from 0 to 90 degrees. So that's why this one, the whole one is 90 degrees. Okay. So if this is theta here, this angle is going to be 90 minus theta. Just imagine if this was 20, that means this is going to be what? 70. Okay. So how do I get 70? 90 minus 20, it gives me that 70. So that's how I wrote this 90 minus theta. Okay, now let's pay attention to this triangle. This triangle is 3, has an opposite of 3 and an adjacent of 4. So that means if I were to calculate sine for this one is sine theta is 3 over r, r being my radius, my hypotenuse, sorry, not radius, my hypotenuse. Okay, and then cos would have been 4 over r. Okay, now if I come to the other triangle, now the right angle triangle is here and the angle is over there. If I do the same thing, calculate sine. Sine is 4 over r now, and then cos 90 minus theta is now 3 over r. Notice what has happened here. What was sine has become cos, and what was cos has become sine. So basically that is what this whole concept is all about. So that means whenever we have a reduction that involves 90 minus theta, we acquire the sign that is given by the quadrant, and the only thing that you do is that you change sine into cos and then replace the bracket with theta. So as you can see here, cos 90 minus theta is the same as what? As sine theta. So what has happened is that the sine, the cos changes to sine, and then the bracket just becomes theta. So that's the only thing that we do. Then what happens if now it's 90 plus theta? So that means on top of this 90, I just add 90 degrees. So adding 90 degrees on top of 90, imagine if your theta is 20. So theta being 20, if you add 90 on 20, it is going to give you 110. So now 110 falls into the second quadrant. But we use the concept that we have established on the first quadrant. So that we're not going to do a triangle here because there's no opposite and adjacent this side to be able to establish this sine and cos. But we transfer the information that we have already discovered here into the second quadrant. The only thing that we do is we use the sign of the trig function that will be on the second quadrant. What do I mean by that? Let's look at this example. We've got cos 90 plus theta. Okay, so cos 90 plus theta is on the second quadrant. Now, what is the sign of cos in the second quadrant? Cos is negative. So that is what I do. I write negative here. And then after you have done that, we said whenever there's 90 degrees, the cos changes to sine. So I change cos to sine, and then the bracket, you replace it with theta. That is what I have done. So that is the final answer of this. So what you do is you look at the quadrant. So 90 minus theta is on the first quadrant, and in the first quadrant, all of them are positive. So there's no sign that's going to change. The only thing is that sine function changes to cos, and then cos function changes to sine. We don't normally have the ones that involve tan, but I have written tan for you over there in case you meet a case like that. But usually the ones that we work with is sine and cos. Okay, and in the second quadrant, we use this information, and by information I mean you're still going to change sine to cos or cos to sine whenever you have 90 plus theta. but the only thing that is going to be different is that you must you must use the sign that is in this in that quadrant. Okay, so that's what I have written here. So what was the opposite for theta is now the adjacent for 90 minus theta. So this is just summarizing what I have just said there. And then sine theta, 90 minus theta is equals to cos theta, cos that is equals to sine theta, and then tan 90 minus theta will be the reciprocal of tan theta. Okay, now on the second quadrant, like I've said, we just use the information that we got from the first quadrant by changing the sign to cos and cos to sine, and then you use the signs that are here. So remember, we said sine here is positive, sine is positive, cos is negative, and tan is negative. So that is why, because sine is positive, the answer is going to be positive. Because cos is negative, the answer is going to be negative. Because tan is negative, the answer is going to be negative. I hope that it is going to be clear. Okay, now I've got a second example here, which now says cos 270 plus theta. Now you've seen we only deal with 180 or now 90. Now they've got this 270 here. Okay, so your little diagram here, we've got 0, 90, 180, and 270. So that means 270 plus theta, I've already passed all of this 270 degrees. Plus theta, that means I am now on the fourth quadrant. So if I add theta here, it pushes me into the, remember theta represents an angle that is acute. So if you say 270 plus 20, it will push you into the fourth quadrant. So what is the sign of cos in the fourth quadrant? Cos is positive in the fourth quadrant. That is why the answer here is positive. And then all you do is you replace cos with sine, and then the bracket you replace with theta. That's it. Okay, and then here you've got sine 270 minus theta. Okay, I've got 270 here. If I subtract an acute angle from 270, so 270 minus 20 will give me 250, which pushes me into the third quadrant. So third quadrant sign is negative. So that is why my answer is going to be negative. So I write that that negative, and then sine changes to cos, and then the bracket becomes theta. Okay, so that is all. So please do exercise 2, and then exercise 2, number one, do everything. Number 2, AC. Number 3, A, B, C, D. Okay, you see that I was a little bit disturbed there. Okay, the reason why we are using the idea of 90 here is because 270 is actually 180 plus 90. So that means this one has a concept of the 90 in it, or you can imagine it as what? As 3 times 90. So this 270 is is involving the 90 that we have, but in multiple form. It is involving the 90 that we have in multiple form. That is why we are using this concept that we have established there. So that is why we have used the same ideas that we have done above. Okay, so I hope it will be clear. Thank you.